Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we're looking at how you find the distance between 2 points on a line. Now, given any 2 points, A and B, with any coordinates x1, y1 and x2, y2, that are a distance d apart, you'll have something like this. So any 2 points, that's the distance they are apart, and those are just the general coordinates for A and B. We can make a right-angled triangle, like so, and then having done that, the vertical height of the triangle, this distance here, will be the difference between the two y values, y2 minus y1. And the horizontal distance along the bottom, that'll be the difference between the two x values, x2 minus x1. And then, using Pythagoras, we can find what d must be, which is the square root of the difference in the x values squared plus the difference in the y values squared. Okay, example 1, the first question is very straightforward. The second one, just be careful with the minuses. Minuses always make things a little bit more fiddly. Anyway, have a go yourself first. So pause the video and then come back to me again when you're ready. Okay, let's have a look at these. There's no tricks, no catches. You just put the numbers into the formula. So for question 1, x2 is 5, x1 is 2, y2 is 11, y1 is 7. And if you pop all those in, you'll get that. That gives you the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, which is root 25, which is plus 5. Now, normally when you take a square root, it could be plus or minus, but distance is a scalar quantity, and it has to be positive. So d does equal plus 5. The second example, as I said, just walk carefully with the minuses. Now, in terms of which point you do take away which one, I could do the second point, take away the first point, and that is what I'd normally do. But equally, I could do the first point, take away the second point. It doesn't matter which order you do. The thing that does matter is that you're consistent for both the x and the y coordinates. So if you're doing the second one, take away the first one, you must do that for both coordinates. Or if you're doing the first point, take away the second one, then again, that is fine, but you must do it for both coordinates. Now I've chosen to do the second one, take away the first one. That'll give me 3, take away minus 2, and minus 17, take away minus 5. So lots of minuses here. 3 take away minus 2 is 3 plus 2, which will give me 5. Minus 17 take away minus 5 is minus 17 plus 5, which is minus 12. Now, whatever number you get here, you are about to square them. So it is really only the difference that matters. 5 squared will give me 25, and minus 12 squared gives me plus 144. Adding those together will give me 169, and the square root of 169 is 13. Okay, example 2. Now, you may or may not have heard of Herons' formula. It's a formula for finding the area of a triangle where you know all 3 lengths, but you don't know anything else. And one version of Herons' formula is the following: that the area of a triangle can be found by doing a quarter of the square root of 4a squared b squared minus a squared plus b squared take away c squared, all squared, where a, b, and c, those are the 3 lengths of the 3 sides of the triangle. Okay, find the area of the triangle with these 3 vertices. So corner A, vertex A is 1, 4, corner B is 4, 8, and corner C is 6, 16. The first thing you'll have to do is find the lengths of the 3 sides, AB, AC, and BC, using the formula for the length of a side, then substitute those into Herons' formula. I'll let you have a go at doing this yourself first. So pause the video, have a go, and then come back to me again when you're ready. Okay, let's follow this through. So first of all, I'm going to find little a. Now, little a, using the normal convention, is the length BC. And that will be the square root of 6 take away 4 squared plus 16 take away 8 squared. which gives me root 2 squared plus 8 squared, which is the root of 4 plus 64, which is root 68. And I'll leave it as root 68 for the moment. I won't write that down as a decimal. With this sort of question, it's normally better to use the exact value, which is that. Okay, that's what we found. Now we'll find little b, and the length b will be the length from A to C, which is the root of 6 minus 1 squared plus 16 minus 4 squared, which is the root of 5 squared plus 12 squared, which is root 25 plus 144, which, like on the previous question, is root 169, which gives us that b is 13. So A is root 68, b is 13. We still need to find c, and c will be the length from A to B, which is the root of 4 minus 1 squared plus 8 minus 4 squared. That gives us the root of 3 squared plus 4 squared, which is root 9 plus 16, which is root 25, which gives us 5 for the third side. So we now know the three lengths, A, B, and C. To find the area of the triangle defined by those three vertices, we just need to substitute those three values into the formula. So there's the formula. Putting the values of A, B, and C in will give us that. Multiplying those out simplifies to this. 45968, take away 44944 is 1024. And the square root of 1024 is exactly 32. So the area is a quarter of 32, which is 8. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 98 and have a go at exercise 5G. Thank you very much for listening, and cheerio.